Hello, my name is John Baugh, and I will be showing you how to program in C++ using Visual Studio 2010. I've created some materials that are available on my website at profjpbaugh.com, profjpbaugh.com. There will be a link on the YouTube page so that you can access it. The name of the book that I'm working on that's available for free is A First Course in Computer Science with C++ Programming. We'll go through a few examples and go over some basic information, and you can read the materials that accompany this, but some people are better with visual learning, so this is kind of like a short classroom setting. Not completely the same, but not entirely different from what I would do in my daily work teaching at the community college, at Oakland Community College in Farmington Hills, Michigan. Okay, so first off, this book that I'm working on and the accompanying materials would serve as a good supplement or even a good primary set of materials for a first computer science course, or if you need to review C++ programming. So this book and the materials are really for anyone who wants to learn. This first lecture will be pretty dry and kind of straightforward. So if you're familiar with Visual Studio 2010 and you're familiar with computers, or you know another high-level programming language like Java or C#, I would recommend maybe foregoing the majority of this lecture, maybe just going over brief parts of the accompanying materials, or maybe a little part of the video here and there, just to get familiar with Visual Studio if you need to review, and then going on to the subsequent materials. So this one will be kind of boring and not as much about C++ as it is about general computing. The assumptions that I make are that you can type, that you know how to use the internet, which you probably do if you're watching this video, and that you have basic mathematics skills. You don't need to be a math whiz, but it does help in some of the things that we'll be doing, because a lot of the data we'll be working with will be numeric. Also, you should have an integrated development environment, which consists typically of a compiler, debugger, linker, loader, text editor, etc. The one that I'll be using is Visual Studio 2010 Professional. You can obtain a copy of this IDE by either purchasing it from a distributor directly from Microsoft, or you can obtain it for free if you have a .edu mailing address and your educational institution participates in DreamSpark. You can go to dreamspark.com and find your educational institution there and see if they participate, and if they do, then that means that you should be able to download the professional edition for free. If you don't have a .edu mailing address, or your institution doesn't participate in DreamSpark, and you don't want to purchase a copy, then I'd say you could get away with using the Express edition, Microsoft Visual C++ Express 2010. That's available on their website as well. Check my website for links. Firstly, we have to go over what a computer is before we get into programming. So what's our motivation for this? A computer is an electromechanical device that can perform computations and make decisions at speeds millions, billions, or even trillions times faster than a human being. What this means is a computer does a whole lot of mundane tasks that would take a human quite a bit of time. A computer can do it very, very quickly and get it done in a very short period of time. Computers, typically when I say computers, people are thinking about desktop computers or laptop, notebook computers, netbooks, things like that, but other devices are actually computers. The tablet computers, your cell phone, even the dumb ones, the ones that aren't really the smartphones like the Android or iOS devices, are actually computers as well. Your Xbox 360 or your PS3, your Nintendo DS, whatever you have, your Wii, they're all computers really ultimately. Now, albeit special purpose computers, they are all computers. Modern refrigerators, microwaves, other appliances, and your vehicle all have extremely large amounts of computing components, especially as they're newer. Computers essentially are made up of hardware and software. The hardware of the computer are the things that you can touch. They're tangible. So the examples would be the motherboard, the central processing unit, the RAM sticks that are inside, the memory, which is the RAM, and other hardware components. There are also hardware components that are not actually inside the computer called peripheral devices. These are things like your mouse and your keyboard, and printers, scanners, etc. These are all computing devices in their own effect. They're hardware that integrates or that interfaces with your computer, but they're not inside the computer. But this is all hardware because you can touch it. Software are the intangible parts of the computer. So, in other words, you can't actually touch the software. Okay, in a desktop computing environment, software is typically categorized as system software, which would consist of the operating system and supporting utilities, or application software, which generally consists of programs that users run for information, entertainment, and productivity. So when we're talking about system software, we're generally including the operating system in that. That would include different operating systems like Windows XP, Windows Vista, Windows 7, Windows 8, Linux. There are different flavors of Linux, such as Red Hat, SUSE, Knoppix, Ubuntu. It would also include Unix, and it would include Mac OS 10, which is the current release. The application software, examples of application software would be things like productivity tools like Microsoft Office, which consists of Word and Excel, PowerPoint, Access, and other applications. Your video games, web browsers, these are all application software. They're not actually intended for the fundamental support of your computer running or the interface operating. In the next section, in section 1.2 in the current release of my book, this is on programming. Since this book is on C++ programming, we kind of have an idea what computers are, so why do we need to program them? Well, computers and scientists and software engineers are primarily concerned with software development. So the software is the primary importance. Now, as computer scientists and software engineers, it's good to know about the hardware as well, but the software is our primary focus. In order to get a computer to perform a set of operations or accomplish a task, we have to tell it what to do. This is the essence of what computer programming is. In C++, as well as many other what we call high-level languages, we'll get to that in a minute, in C++, we give the instructions, or the computer instructions, in the form of a set of instructions called an algorithm, which is a well-defined, unambiguous, finite set of instructions to perform a task. Now, that's the formal, kind of a formal definition. Well-defined means that it has to be clear. You can't leave room for confusion. Okay? And it has to eventually stop running, which means it has to be finite. So I can't just have some set of instructions running for eternity. It's not really an algorithm at that point. And there are different high-level languages, different types of languages, like C++, Java, C#, Python, Visual Basic, Objective-C. These are all high-level programming languages. These are closest to English. There are other categories of languages, such as the code that the computer understands directly, which is called machine language or machine code. These ultimately consist of the ones and zeros, which represent high and low electrical signals, and the computer interprets those directly. That's the only thing the computer understands, are the zeros and ones. Now, it is possible for humans to write machine code, but usually the people who do that, who ever do that nowadays, or who know how to do that really well, are maybe electrical engineers from the 1970s that are generally locked in dungeons and fed bread until they need to be unleashed on society occasionally for their esoteric knowledge. But we don't really program like that very often anymore. Now, assembly language is a little bit higher level than machine language. Assembly language might consist of instructions like load number 1, add number 2, subtract number 3, store result. Okay, it's a little closer to English, but it's still pretty tedious. It's a lot better than machine code, though. So once they developed assembly language, eventually programmers wanted something more. So eventually high-level languages were developed. And as I mentioned before, there are many, many different high-level languages. These languages consist of C, which is C++'s predecessor, and Java, C#, Visual Basic, Python, PHP, Ruby, Go, languages like that. In section 1.3, I go over the basics of interface types. Now, there are different types of interfaces. The two primary categories of interfaces include what are known as GUI interfaces, such as the calculator program on your computer. This is a GUI interface. Okay, it's not GUI because it tastes like fudge and is really creamy and delicious. It's GUI because that stands for GUI. That's graphical user interface. So if I want to calculate something using my calculator, I can click these buttons on here, and I will get something displayed in this label or text box. Okay, and these are all components. These components wait for an event to occur, namely for buttons to get clicked. That's a GUI interface. Now, the interfaces we'll be primarily dealing with in our exploration of C++ is a command line interface. Now, just so you can see what it looks like, I'm going to go under All Programs, Accessories, and bring up the command line just so you know what the command line looks like. And before there were graphical user interface operating systems, at least readily available, the majority of people interacted with computers, or it wasn't the general populace. In fact, GUI was what made the general populace, or made computers easily acceptable to the general populace. But command line interfaces are still very common and used quite frequently. Actually, a lot of things that are done behind the scenes are done with text-based commands, and that's what a command line interface really does. So if I want to know what's in this particular directory, I type a dir and it will list stuff in the directory. You don't really need to know this, but I'm just showing you what a command line interface looks like in general. Now, Unix, generally a Unix operating system, you're interacting with it almost entirely with command line interface. So that, if you're coming from a Unix environment, that would be very, very familiar to you. So I'm going to close that for now. Okay, so the next thing is we want to write our first program in C++ using Visual Studio 2010. So what we're going to do is we're going to start Visual Studio 2010. It's this symbol. It looks like an infinity symbol, and the 2010 version, the edition that I have, looks like it has purple on one side and blue on the other. Generally, it's under All Programs, Microsoft Visual Studio 2010. Notice I do have another version of that on here. I also deal with the 2012 version, which is out now, but I don't recommend learning on the 2012 version just yet because it's still got some kinks and bugs to work out. Visual Studio 2010, you click that and open it. Often you might have a shortcut on your desktop depending on what you decided to do when you installed. So this is ultimately what we have when we have Visual Studio started. So how do we create a new project? Well, the code that we'll use will be inside of projects ultimately. And we need some terminology out of the way first. In Visual Studio, this is not the same in every compiler or integrated development environment, but in Visual Studio, you have solutions which are basically containers for projects. So a solution is one or more projects, and a project contains one or more files and resources that make up that project and solve a problem, we'll say. Now the problem may be very small, like performing a small calculation, all the way up to a video game. You might have 1 or 2 or maybe 15 projects within the same solution to solve that. But Visual Studio, regardless, will give you a solution, and you'll have a project underneath, and then you'll have your files. So a lot of people consider that maybe overcomplicating things, but it's actually quite organized once you get used to it. Now I could click New Project right here, but if you don't want to click that, or let's say you don't see the start page, you closed it, the standard way to start a new project, this is all empty if you'll notice, you go to File, New Project. Okay, it's also Control-Shift-N. Once I start this new project, it will ask me what kind of project do I want to make. Now you'll notice that I actually have other languages loaded here, like Visual Basic, C#, Visual F#, but we're dealing with Visual C++, so you want to make sure that you have Visual C++ listed in the new project dialog box, Visual C++. Then you want to make sure that you have Win32 console application selected, and then what we're going to do is we're going to change it to a directory that we want. In this case, I'm just going to use this standard directory right here. Okay, so I'm going to name this project, we'll say L1 examples. Okay, and make sure that you have create directory for solution checked. It is by default. Now if you want to change the location, I just happen to have my solutions, my projects stored here, but if you want to, you can click Browse and then look for a location. So another, I guess, assumption that I make is that you have at least a fundamental understanding of file management and how the file system works. Okay, so you change it to a location you want, or you can keep it in the default location that Visual Studio puts it in. It doesn't really matter. So it'll say the name of the project is L1 examples. By default, the solutions name will be the same. You could change this. I typically just leave it alone. Okay, so Win32 console application under Visual C++. Change the name to something useful, and change the location if you want. Make sure create directory for solution is checked, and then you click OK. Once you do this, this application wizard will pop up. It said, therefore, console application, you want to click on application settings, and then you want to, this is the one difference from the default that you'll need. I just want you to click empty project. Very important. Make sure it's on console application, empty project. Then you click finish. Once you've done this, you'll notice over in the Solution Explorer, now one note about the Solution Explorer, this will show you everything inside of your solution. And this first thing up here with this little triangle next to it is the project. Okay, this is the first project inside of the solution. Now, some people have their Solution Explorer docked to the other side. That's, I think, the default with 2010. In previous versions of Visual Studio, it was docked over on the right side, and I just happen to prefer it there. So you can really dock it anywhere you want. I think that's kind of stupid to dock it on the bottom or the top, but you notice this interface allows you to dock it wherever you want it. So I'm going to just keep it over here on the right. Now, you notice there's different folders here within your project. There's external dependencies, header files, resource files, and source files. What we need right now are just source files. So I want you to right-click Source Files. I want you to go to Add, New Item. Okay, so we created a solution which contains a project, and now the solution was empty, and now we're going to add something to it. Now these are all the options that we have for different types of files that we could add to our C++ project. What we want is a C++ file. This is C++ file.cpp. This is what we call a source file. Okay. Now, in this case, you're going to give it a name that's useful. I'm just going to call mine main.cpp. That's just kind of a standard convention I use unless I have a reason to name it something else. C++ is not like Java. If you're coming from the Java world, the name of the file essentially has to be the name of the class that everything's within, but in C++, not everything's inside of a class. We'll get to that later on and discuss where classes fit in and object-oriented programming and everything like that, but for now, just name it something useful. You could name it sausage.cpp, it doesn't really matter, but it probably wouldn't make sense if you're just doing a simple program that has nothing to do with sausage. So, main.cpp. CPP stands for C++. You can't really use the plus symbols because it means something else in file management. You might also, on rare occasions, see CXX. The X's look like plus symbols on their side, so it is considered an acceptable file extension to have CXX. Okay, but CPP is generally more accepted. Okay, so make sure CPP file, name it, click Add. You'll notice now that it opens the main.cpp file. Under source files, I have main.cpp listed over here, and then in my text editor portion of Visual Studio, I have the blank file. I'm going to start adding some text to this, some code, and don't worry if you don't understand this. You probably won't if you don't have any programming experience, but this is a skeleton program right here for C++. We have include IOStream. This includes what's called the IOStream or input-output stream library. We'll cover that in more detail. So a lot of this I'm just going to have you accept on faith. Programming is often like a chicken and the egg problem. So I have to describe the chicken to you before you can see the egg and vice versa. So a lot of this is going to be really kind of foreign to you, but that's okay. You just kind of do it verbatim, and then you go back and you learn, well, what does that actually mean to include something? What does using mean? What does namespace mean? All this other stuff. So we'll explore more of that later, but right now we have to get our feet wet. Okay, so include IOStream and using namespace standard. This is so in a second when we go to print to the screen, we don't have to preface one of the variables with std each time, which stands for standard. But right now what I'm going to do is I'm going to print something to the screen using a variable which is made available to us in IOStream. This variable's name is cout. Now what that stands for is console out. Okay, the console, remember we talked about command line interfaces. The console is basically that black thing that you can type into that I brought up earlier, the command line. Okay, you use cout and then you use two less than symbols. Together these are called the stream insertion operator. Okay, because you're inserting data from your program onto the console. Okay, now I'm going to do an open double quote. I'm going to type hello world exclamation point, close double quote. Then I'm going to do this. I'm going to do stream insertion operator again. Then I'm going to type end L semicolon. Okay, now for clarity's sake, I'm going to hit enter just to put some space between this and the return 0. Couple notes here. Main is what we call the entry point of C++ program, console program at least, and it's delimited by these two curly braces. Many high-level languages are delimited by curly braces and have this very similar functional syntax. Some don't. Some have actual end statements or end function statements, but that's not the case with C++. Int main, and then open and close parentheses. This is the entry point, and then you have return 0 near the bottom. Okay, this is essentially the skeleton of a C++ program. This return 0 right here basically tells the operating system there weren't any errors, there weren't any problems. So when your program's done executing and the program terminates, it returns control back to the operating system and says there were no errors. So again, this is one of those things you just have to kind of take on faith. Don't worry about it too much, and just focus on the line that we wrote here. So you have cout, stream insertion operator, double quote, and then I put a string that I want, a text string that I want to print out, then a close quote, then another stream insertion operator, and then end L. So let's build it. This is essentially the process of compiling and linking. You go to build solution, or you can hit F7. When you're done building, you look down here in the output, and it should say 1 succeeded, 0 failed, 0 up to date, 0 skipped. Okay, so since it's succeeded, that means that we don't have any syntax errors. It doesn't mean that the program is bug-free necessarily. It just means that there are no compiler errors. There are no errors that are involved in the syntax or the grammar of the language. It means there could be some sort of logical error and the program could blow up on us, but I'm going to doubt it for now. 1 succeeded, so that means we're good. So once we've built it, that means that the executable file, which is in the computer's machine code, has been created out of our high-level language. Now remember, computer can only understand its machine code. The computer doesn't understand this gobbledygook here. It only understands ones and zeros. This entire program, the whole purpose of a compiler is to convert this high-level C++ into code that the computer understands, namely its own machine language. So we built it, we created that file, then I go to debug, then I go to start without debugging. Okay? If I was trying to find a bug, I would go to start debugging, but right now I just need start without debugging just to run it. Okay, and now the console pops up, says hello world, exclamation point, like I said to print. Now, what about this press any key to continue? Now, we didn't put that string. That text string is nowhere in our program. Well, that's true. This actually is part of the Visual Studio's environment. So basically, when you run it from Visual Studio, it's going to put press any key to continue. And that's okay. It's not actually part of the code that we wrote. So just get used to that being there. When you hit a key, it'll just close the program. So that's essentially our first program in C++. So just as a brief review, I'm going to go to File, Close Solution. It may ask you to save it. If it does, you just save it. And to create a new project in Visual Studio 2010, you go to File, New, Project. Okay, go to Win32 console application. You give it a under Visual C++. Make sure it's under there. Win32 console application. Change its name to something useful. We'll say L1 try 2, just because I don't want to. You can't have the same name as another solution in that folder. And I'm going to click make sure Create Directories for Solution is checked, which is default, so that's good. And you click OK. Then the step that a lot of people skip, which is very important, they get very confused and discouraged, is you go to Application Settings and check Empty Project. Then click Finish. Then you go back to Source Files over here. It might be on the other side. Right-click, Add, New Item. Okay, then you go to CPP file and name it something useful. Okay, main.cpp is a good standard name. And again, this is your skeleton. I'm repeating this because it's very useful to go through something more than one time. Now you could repeat the video, but I'm making it easy on you. Okay, so include IOStream using namespace standard, and then this is the skeleton of main right here, the entry point. Now, what happens if we build and run it right now? Okay, you build it, it succeeds, start without debugging. It just says press any key to continue. It's because our program doesn't do anything really. It just starts and then is done. But to print something, let's print out our names. So you do cout less than, which is the stream insertion operator. And then in double quotes, I'm going to put my name. And then endl. Okay. I'm going to build. And then I'm going to start without debugging. Okay. Now, what happens if we add another endl? Okay, so we got two endls. Now make sure that they're separated by the stream insertion operator. What happens if we have two endls? Start without debugging. Notice there's an extra space here. So try to think about what endl actually does. Okay. Another thing to note is the semicolon. Many high-level languages like Java and C++, C# require that a programming statement end with a semicolon. Now if I take the semicolon off and I try to build it, I will get a compiler error. If you look down here, it says 0 succeeded, 1 failed. Now if I look up in this mess right here, you should see an error, and it says syntax error missing semicolon before return. So that means sometime before the return statement, even though it's underlining this, the return statement's fine. So you have to kind of look around it and see what might be causing the error, and then you look and say, oh crap, I'm missing a semicolon. You can even double click any of the errors down here, it'll point to around where the error occurs. So you look at this and you say, okay, well, I need a semicolon, so I'm going to add a semicolon. Make sure you add a semicolon and not a colon. A semicolon is like the dot over a comma, essentially. It's next to the L key on the keyboard. It's to the right of the L key. I'm going to build it and start without debugging, and we're done. So that's our first lesson in C++, and I hope that you watch the other lessons. Again, go to profjpbaugh.com. It's PROFJPBAUGH.com. Thank you, and I'll see you in a little bit.